Hello, scholars. I wanted to do two things. Hopefully it won't take too long. I wanted to talk to you about the difference between organic and inorganic objects, and also mention the matter of curvilinear bias. And so let's start with the organic versus inorganic. And I'm just going to make a list up here. These are two categories that are both present in nature. The organic, however, includes everything that is alive or has lived. And so if we take these two objects, a rock and a shell, this is inorganic, natural, because it was alive at one point. The reason that we're distinguishing these things is because we're going to find that drawing organic objects actually gets you further along in your artistic development. If you decide to draw an inorganic object, you're going to benefit by that because it's always beneficial and a challenge to draw something, observe it, and record it accurately. But there are things about organic objects that get you further along, and I'll explain that after we go through this list of distinguishing characteristics. If we were in class, this would be more of a discussion, and I would challenge you to think about the differences. You're welcome to pause this at any point and think about what are the differences between inorganic and organic. And I know most of you won't do that, but it might be a good idea. Inorganic objects are non-living. And so when we make this list, we'll make a list of opposites, basically. So living or has lived, of course. If we think about, especially in visual terms, the differences between these two things, we actually can learn some interesting things. So if we think about why this is the way it is, we find that its appearance is the result of external forces. So it's shaped externally. And what I mean by that is that this used to be bigger, and either erosion or some kind of concussion or water freezing and thawing, any kind of external force made this into what it is. On the other hand, over here, these are internal forces because this conch shell went from being a very tiny thing, it developed, it got bigger, and it actively grew. So that's an internal force versus an external force. And if we draw a picture, sort of a schematic, we would say that this is the result, the shape is the result of external forces, and the conch is a result of internal forces that grew out. This would be also passive. In other words, it doesn't act on its own. It just receives external forces, but this is active. There's one other really important thing that, this is probably the most important thing, and it's related to these. This is the way it is because of an internal code. So there's order here that makes this the way it is. So we're going to say that this is order, and this is chaos over here. Oh, I should say, let's say random instead of chaos. This is the way that it is because of random forces, these things that we've mentioned. This is the way it is because of order, in this case a DNA code, which guarantees that this is going to be this shape. And we have conch fossils that are millions and millions of years old that are just like this. So we know that this works pretty well over millions of years to guarantee that this will come out the way that it's supposed to be. So why does that matter? Well, here's the reason that it matters. If you draw this, you're going to heighten your sense of beauty in design, because this DNA code guarantees that this conch shell is going to have certain proportional relationships that basically define our sense of beauty. Our sense of beauty comes from nature, and the proportional relationships that we see in nature govern what we consider to be beautiful. So if you have a chance to draw and you are wondering which I'm going to draw, you're going to get more out of this because of the proportions that are part of this this shape, whereas this is just random. So if you have questions about that, please email me. It's kind of interesting, but the basic idea is that if you draw organic objects, you're going to get more out of it because it's going to heighten your sense of beauty. Okay, there's a practical concern that always comes up about this point at this point, because we're drawing more complex things, and so what I've discovered over the years of teaching is that virtually everyone has a bias. We'll say call it a curvilinear bias. A bias is a tendency towards something as opposed to a prejudice, which is against something. So we tend to exaggerate. This is the definition of curvilinear bias. The tendency that we have to exaggerate curves in objects that we see. We're starting out drawing shells because while they do have curves, they're very angular. So it's just easing into dealing with this curvilinear bias. So what it means is that that when you draw something, you're going to exaggerate the curves. I don't know why. It just happens to be the case virtually 100% of the time, unless you can overcome it. And we're overcoming it by practicing the techniques introduced in class. So remember that we're drawing through, we're mapping out. Drawing through and mapping out will virtually guarantee, if you follow through with it, that you're going to overcome your curvilinear bias. It will feel like you're exaggerating the angularity, but you won't be. And when you develop something like this, it's very angular, it's going to be more accurate, and then when you're finishing the drawing, you can soften some of the angles, and you'll have an accurate drawing. The opposite of that is making things way more curvy than they really are. You usually end up with something that looks like a bread dough or a big marshmallow. You don't want that, I'm pretty sure. So if you have questions about curvilinear bias, email me. That's it for today. I miss you. Bye-bye.